Okay, so we did chapter 8, but now we're going back to chapter 7. And so one of the things that we're going to do is the Pythagorean identities. But in order for us to move on, we need to do a little bit of review because in order to do some of the material that's coming up in chapter 7, we are going to have to know how to add and subtract and do these types of problems right here. But instead of having x and y, we're going to have the trig functions in there. So we need to know how to manipulate these, and they were given in chapter 0, but we need to know how to manipulate these. So when we get these filled with instead of x cosine of x and instead of y sine of y, we're going to be able to do it. So instead of having that, we're going to be able to do the manipulation and the algebra. Now there's a couple of ways that we could do this. This is a simple problem. It's a complex fraction, and this complex fraction is 3/5 divided by 5/8. So that's a division symbol there. So we have a fraction divided by a fraction. I'm going to get rid of that. But that is a fraction divided by a fraction. And so when we do this, you could do the very easy 3/5 and then divided by 5/8. And then you would end up flipping it. And so we would get three, you cannot cancel these because it's division. We have to do this process first, and then we get over 8/5 because you do the reciprocal of that one there. And then here we end up then getting, when we look at that, 8 times 3, which is 24, and 5 times 5, which is 25. And that's the normal way to do it. Now, I want to actually, because you're going to get complex fractions here, I want to introduce you to something that's a little bit different. We did it before, but if I see that it works and I get the same answer, 24/5 there, then if I do it this other way, when it gets more complex like these, that process works for those as well as it will work for this. But if I want to try this process here to this, it'll get more complicated. So I want to do the same process for all of these three and make it much easier. So in order for me to do that is I look at the denominator of the numerator, which is 5, and the denominator of the denominator, which is 8. And then I am going to get the lowest common denominator. So I take the biggest number, 8, and I keep multiplying it in this case because it's a number. I multiply it by 2. Does 5 go into 2? And then does 3 go into, I'm sorry, I take 8 and I multiply it by 2, and so I get 16. Does 5 go into 16? No, it doesn't. So then I go to 3, 24. Does 5 go into 24? No. And then I keep going and going until I get something that actually goes, and they both go into. And we did this before. Remember, we called it the lowest, oops, we called it the lowest common denominator, and it turns out to be 40. They both go into 40. So now what do we do? Well, this is what we're going to do, is that we're going to take this 40 right there, and we are going to multiply this by 40 over 1 to the numerator, and we're going to do the same thing, 40 over 1 to the denominator. So we're multiplying the numerator and the denominator by that. And so what happens, because they both go into 40, what's going to happen is that this 5 is going to reduce to that. I could do that because it's multiplication. We're not doing cross multiplication because this is multiplication, not an equal sign. And so then we end up reducing this, and then 5 goes into 40 8 times. And so we end up getting 24, and then the 8 and that 40 cancels, and that's going to give us the same thing that we had over here. And so 8 goes into 40 times 5 times, and we end up with 25. Now, again, open mindset. I know that this looks a little bit more harder, and this is easier because you're used to doing that, but we want to change the way you do problems, because while this might be easier in this problem, it is not that much easier here. But we want to use the same concept that we learned here on that. And so notice how we got the same answers, and all we had to do was do the common denominator. Some of you might look at it and say, wow, that's much easier, which is great. Now you have another thing in your toolbox to put on there and be able to solve this. So now let's use that same one. I'm going to erase this one here because I don't want to use this concept right there. I'd rather use this concept where we get a common denominator. Now notice here how this here, x, y is in the numerator, and this is in the denominator. So that's what we want to do. we want to actually do the same thing. This quantity is being multiplied by that quantity. So what I am going to do is I'm going to take this xy and put it over 1. And then I'm going to have 1 plus x plus 1 over y. And some of you might look at it and say, well, I'm going to get a common denominator for the denominator and solve for it. And well, that's not what we really want to do. We want to use this method over here. So what we do here is the denominator in the numerator is 1. So this is our denominator here. And then the denominator has 2 denominators. And so it's this x and this y. So I'm going to take these 3 and get the lowest common denominator. Now, because there's no numbers, I don't need to do what I did over here when I got the 40, but I want to just get this a common denominator. And what it means is that it has to have an x, a y, and a 1. But a 1, anything, you don't need the 1. So the only thing that we have here, the lowest common denominator on this one is going to be x times y. So what we do here is we're going to multiply the numerator times xy over 1, and we're going to multiply this one here as well, and we're going to multiply times xy over 1, and this here is a quantity because of that plus sign. So I have to put parentheses on there because what we're going to do is we're going to distribute it to each part of it. So I'm multiplying the whole denominator by that and the whole numerator. So what do I get in the numerator? When I multiply these, because these are the quantities, I'm going to get x squared, y squared, and I don't need that 1 there. And then what's going to happen here is I am going to write it over here when the distributive part. So I'm going to take this part here, and I am going to take this part here and what happens, and I am going to put that over in this space right here. Okay, so what we're going to do with this one, I am going to do that in purple. So I am going to take the xy and distribute it to the first one. So I'm going to take the xy and I over x. So it's numerator to numerator. So it's numerator to numerator because I'm distributing it, and then that x that belongs there, and then we have that plus, and then I distribute that again, and I'm going to get xy over 1. I'm sorry, over y, because it's numerator to numerator, so xy over y. And what happens is that, and this always happens, if it doesn't, then that means you did not get the lowest common denominator. This x is going to cancel, that y is going to cancel, the denominator is going to go away. So what you're left with is going to be y plus x, and now it's no longer a fraction. And I cannot cancel this x, and I cannot cancel this x. These two x's I cannot cancel, and I cannot cancel this y and this y because of this plus sign. You could only cancel when it's being multiplied. So this x and y squared, these could be canceled if this wasn't a plus and it was multiplication. So your final answer here is going to be this here. It seems like a lot, but it really isn't. I just spoke a lot and walked step by step on there. But if you actually look at it, all you did was get a common denominator, multiply numerator, numerator, distributed numerator, numerator, and then you got your answer. Now here is going to be pretty much the same thing. The only difference here is that the numerators were 1, but now the numerators are y and x. So they're going to be the same thing. The denominators did not change. I could still put the xy over 1 like I did over here, and then this x and y. So my common denominator is still going to be xy. So I am going to take this and multiply the numerator by xy over 1, and then xy over 1. This is already over 1. So what we're going to get is the same thing, x squared over y squared, because numerator to numerator, denominator to denominator. And I am going to still get the same thing over here. So I am going to put that, let's say, in this green triangle over here. I am going to put the work for the denominator. So I'm going to do it in green here. So I am going to take this and I am going to then distribute that in there and that in there. So I'm going to get x, I'm sorry, oops, I am going to get y over x times xy. because I distribute numerator to numerator, denominator to denominator, plus x times xy and over y. So what happens here is that the x's are going to cancel, the y's are going to cancel, and we're left with y squared plus x squared, not y's, x squared. And that's what you end up when you distribute this. And so then that's going to be our new denominator. So what we're going to get here when we multiply this denominator is now going to be y squared plus x squared. Can the y squares and the x squares cancel? And the answer is still no because of that plus sign. And so that's what we get there. And so it's not as bad. Just practice a little bit and then you see you'll be okay. Okay, here, how do I do that? Well, now we have secant and cotangent. There's a couple of ways that we could actually solve this. And the way that we could do this, it becomes, if we want to look at it, because we always want to go back to the basics, and the basics is always going to be sine, cosine, and tangent. So this here, what it actually becomes is the secant is going to be 1 over cosine of theta, and the cotangent is going to be the cosine of theta over the sine of theta. And so now you know what is actually happening here. It becomes one of these problems that we talked about over here. It looks like this one here, where we have a fraction over a fraction. It's not as complex as this one, but it is the same way. So what you do here is you're going to take this and you're going to get a common denominator. So in this case here, it's cosine and sine. And so you're going to do the exact same thing that you did before. So we're going to get the lowest common denominator. And the lowest common denominator here is going to be cosine of theta, sine of theta, because that's coming from this and that, the denominators of the numerator and the denominator of the denominator. And so when we do this, we are going to multiply this by cosine of theta, sine of theta over 1. And then you have the big fraction, and then we're going to have cosine of theta, sine of theta over 1. And so what we're going to end up here is that because this is multiplication and that's multiplication and it's one fraction, this cosine is going to cancel with that cosine. So we're just going to be left with sine of theta, and then this sine and that sine. And so we are going to be left with cosine of theta. So we end up with sine of theta over cosine, and cosine is going to be 2 cosine squared of theta. There's 2 of them. These 2 multiplied together gives you cosine squared of theta. Okay, now this could have been very easy and just also just flipped over the reciprocal and multiply across and you get the same thing. Usually when something else is added to the denominator, like it was in these problems, then this one here becomes a lot easier. It saves a lot of steps. Okay, here, what do we do if I have 1 over cosine and 1 over sine? Well, anytime that we have a plus and 2 fractions, that means that we're adding the fractions. So what we need to do is get a common denominator. So that's what it's actually asking us to do. So it's saying that one fraction plus another fraction is going to give us when we're adding them, it's going to give us one fraction. So how do I do that? So the way that we do this is this one here is missing the sine and this one here is missing the cosine. So that's what we're going to do. So I'm going to multiply this by sine of theta and then sine of theta again. And then on this side, I am going to do cosine of theta as well. And so we're going to get sine of theta over sine of theta cosine of theta, because that's going to be our common denominator for both of them. And then it's going to be plus cosine of theta. So if you think that I skipped a couple of steps here, I am multiplying numerator to numerator, so it's sine of theta, and we get sine of theta here, cosine of theta here, and then it's going to be plus cosine of theta, and then again we get the sine of theta, cosine of theta, and they have a common denominator. So if I have a common denominator, I could add the numerators and the common denominator stays the same. So this is what I get here. And so the question is, Can I cancel this sign and this sign and that cosine and that cosine? Again, no, because of that plus sign. That's all I get to do. So that was a quick review of chapter 0 and how to manipulate it. That is going to be more important as we go further on.